All right, so from last time we were playing around with the idea of what are called real numbers. And real numbers, there's a lot of different kinds of real numbers, and the main two divisions we were looking at last time were rational numbers and irrational numbers. Something's a rational number is if it can be written as a fraction of whole numbers or ratio of whole numbers. And irrational literally means not rational, so it can't be written as a fraction. Rational numbers are all our fractions and whole numbers, positive and negative. Irrational numbers are things like pi, the square root of 2, and the square root of 23. The cube root of 7. So there's, just as like there's many different kinds of rational numbers, there's even more kinds of irrational numbers. So I can't begin to show you all possible kinds, but the most common place they come up are with respect to roots. So square roots, cube roots, and so on. And remember what a root is. The cube root of 7 translates as what number would you raise to the third power so that 7 is the answer? Okay. So kind of like the square root of 23 means what number would you raise to the second power so that 23 is the answer? And we can easily answer that questions for numbers like the square root of 4. What number would you raise to the second power to get 4? 2, right? So we know that 2 squared is 4, so that means square root of 4 has to be 2. So square root of 4 is a rational number. If I try to take the square root of a number that's not a perfect square, turns out the answer is going to be irrational. Now, perfect squares can be decimals too. Okay. So for example, whip out a calculator if you don't already have one. What's the square root of 2.25? So get out a calculator. We're going to need one today. I'll get one out too. So SQRT of 2.25. My calculator says it's 1.5. It comes out to a nice number. So perfect squares aren't always whole numbers. They can be decimals. They can be fractions. So is the square root of... Oops, what happened there? Oh, wait, the wrong button somewhere. No. Wait. Nope. There we go. All right. So is the square root of 2.25, is that a rational number or an irrational number?
Rational.
It's rational because it reduces down to 1 5/10, which is a fraction. So this sucker is rational. But if you just randomly pick some number, most likely it's not going to be a perfect square or a perfect cube, and it's going to be irrational. So for example, what if we tried to take the cube root of 2.25? Is it possible that there's a number you could cube and perfectly, that's rational, you get 2.25? And most likely what we're going to find is it's not. And cube roots on a calculator are a little trickier because my calculator does not have a cube root button, it's got a square root button. Some calculators have a variable root button. And so I'd have to look at your calculator to see. Usually if you have a variable root button, it's going to look something like this. It'll say something like X with a root symbol next to it like that. And then it's going to want you to type something like 3 root 2.25, which means find the cube root. So it turns out there's a trick for doing this on almost all calculators. And it's that roots are fractional powers. So for example, the square root of 4 is also 4 to the power 1/2. The cube root of 8 would be 8 to the power 1/3. So a root is the denominator of a fraction in a power. So if I wanted to calculate this number here on that Google calculator, I'm going to have to type 2.25 raised to the power, and I'm probably going to have to put in parentheses 1 divided by 3 is the power. So let's test this out. Look kind of weird. On your calculator, see if you can take a fractional root or a cube root. So on this calculator here, I'll do 8 first because it's easier. What is the cube root of 8 supposed to be? 2. So that's why I'm testing 8. So I'd go 8, then I'd say give me a power. On this calculator, I got to use parentheses on the power because the power is complicated. 8 divided by 3 is my power, and the computer says, yeah, it's 2. And again, I picked 8 so that we can make sure we're using our calculator properly, because we know what the answer is. Is anyone having trouble making their calculator do a root that's not a square root? If you are, let me know. Okay. So on this calculator, we're going to use the x to the y key. So type 8 first, and then hit the x to the y key, and then 1 divided by 3. And close the parentheses. And then equals SS2. Yeah. So on Elsie's calculator, the key to get a fractional power, to get any kind of power, was the x to the y key. So 8, then x to the y, and then parentheses 1 divided by 3. So let's try it for the cube root of 2.25, which I believe is an irrational number. So clear 2.25. Raised to the power, and I have to use parentheses. Every calculator is a little different. 1.31. Now, I don't see a pattern there, and so I'm going to guess that it's irrational. Right? There's a few ways to check, but that's kind of beyond the scope of this class. But trust me, it's irrational. Okay, so it turns out that square roots have some nice properties. So if you took the square root of 2, which is an irrational number, right, and you multiply it by itself, what happens? Well, there's a couple ways to think about it. The square root of 2 says what number would you square to get the square root of 2? Oh, sorry, to get 2. Square means multiply the number by itself. Right? So aren't I taking the number and multiplying it by itself like there? So the answer ought to be 2. Another way to think about it is square roots work nice together. So if you take the square root of 2 times the square root of 2, that's the same thing as the square root of 2 times 2. Square root of 2 times 2 is what? 2. So when you multiply square root by itself, the root cancels because you're squaring the root. Okay? So this is kind of a nice trick. If you take the square root of some number and then square it, you're going to get the number back. Slight catch if x is greater than or equal to 0. If it's negative, weird stuff happens. So Elsie's question from the homework, 23 divided by the square root of 23, the question said rationalize the denominator. So what that means is look at the denominator and ask yourself, is the denominator a rational number? No, square root of 23 is not rational. Okay, how do we get rid of the square root? We can't just erase it. So the trick is we multiply by the square root of 23. because that's going to cancel the root. But if I multiply something in the bottom, what do I have to do to the top? Same thing. So I have to multiply the top by the square root of 23. Cleaning this up, what happens? Well, square root times the square root cancels, leaving just a 23 in the bottom. In the top, I still have a 23, and I had to introduce a square root of 23. So the key thing here was the denominator cleaned up. Is there anything else we could clean up here?
23.
Yeah, 23 divided by 23 is 1. So ultimately, this is equal to the square root of 23. So our claim is, when we try to clean up the denominator, the square root of 23 over the square root of 23 is the same thing as the square root of 23. Let's double check with a calculator. So what I want you to do is whip out a calculator, type this into your calculator, see what the answer is. Try it. So 23 divided by, most calculators have a square root button, 23, close parentheses. My calculator says it's about 4.8-ish. Anyone else getting that? Okay. So I get the original number is about 4.796, I think, to 3 decimal places. And then I check that with the square root of 23, and it seems reasonable because 5 squared is 25, so it should be less than 5, so it seems okay. Calculator says just the square root of 23, all on its own, is same number. Okay, so the calculator verifies that, yeah, there are 2 different ways to write the same number. So that's the idea of rationalizing the denominator. Okay, other homework questions.
Number 19 on 6.3.
6.3, and what's that problem about?
Write the ratio as a ratio of whole numbers in the lowest term.
Okay. And then what's the problem?
0.40 or 40 cents to 30 cents.
That right there. So we're given that ratio and we want to rewrite it as ratio of whole numbers.
Write the ratio as a ratio of whole numbers in lowest terms.
Okay. So problem is this isn't a regular fraction. So what can we do to this to make it a regular fraction?
Move it decimal over to the right.
To the right, yeah. So if I move it over one place to the right, that's going to give me a 4 here. And, oops, wrong color. And since I moved that one to the right one, I have to move that one to the right one. And that's going to give me a 3 in the bottom. So now I have 4 over 3. I want to go.
Right.
And 4 over 3 is now whole numbers. Can I reduce 4 over 3 or is it already reduced? It's already reduced, yeah. Another thing people might do is you could have moved it 2 because of that 0 there and written 40 over 30. That's also equivalent. Is that reduced though? No. How would we reduce that? Yeah, and remember when you do this under extreme conditions like a test, write down what you're doing. Like I'm dividing by 10 there, I'm dividing by 10 there. Don't just think, then that mistakes happen. Yeah, so 4/3 would be the reduced version of that ratio. What's up?
Yeah, on the homework.
Yeah.
I don't know if it's because I leave early, but it had one of the questions was like find the points or something, and it had like
Yeah.
2 and 0, like in parentheses.
Between 2 points.
Mhm.
Yeah, I don't know if it's because I left early and I missed that or.
I don't think we talked about it.
Oh.
We did indirectly. My hope was that you guys would figure it out.
If there was a video, maybe.
Video?
It's right here.
There wasn't.
No,
that
there wasn't
problem?
a video for that problem.
Oh yeah. Sometimes I make sure there's videos on the problem, sometimes I don't. And that's on purpose.
Numbers.
I was like, you like pull out a grid and you like
Well,
you do that. Oh, okay.
I
I should have just done that.
Okay, so here's my version of the problem. So here's what I want you to do right now. Oops, let me put it in a new screen so it looks better.
I graphed it and then I was like, all right, well, it's 5 down, and then -8.
Plot those 2 points. Draw a picture of that, please. I think once you draw the picture, you'll be like, oh, I see.
That's what's going on.
So we have the point -5, -3, and the point 3, 3. Doesn't have to be a perfect sketch, but draw a grid. Mark where those 2 points are. Blow it a little more. -5, -3, and point 3, 3.
I wasn't sure if it was that. It was like countless spaces.
What does it make, Alondra? What's that?
A line?
Is this like the slope or rise over
Yeah, close. Okay, so here's one point, here's the other point. What do I want to find about these 2 points? The distance between them. Okay. Have we looked at diagonal lines recently?
Yeah, with like the TV problem or like any of that, or no, is that totally?
Yeah, the TV problem too, but where else have we looked at diagonal lines? Last class, what were we doing?
Oh,
Pythagorean Theorem. And when we were doing the Pythagorean Theorem, what I said was the Pythagorean Theorem needs distances. That right there is a hypotenuse. If that's the hypotenuse, what's the right triangle? Draw the right triangle that goes with that hypotenuse. You can draw 2 different right triangles, one below or one above. Doesn't matter which one you drew.
you can go this way.
So I could go this way and draw this right triangle.
But since you only
Or I could have done it
you
above.
have to figure out what those 2 are, like versus figure.
Can't we figure out this length easy?
Yeah.
What's the distance from here to here? 8, right? It's 5 and 3. And what's the distance from here to here? 6. So do we now know how to find that length right there? Yeah. So my hope is you would draw it and see diagonal length, hypotenuse.
I was putting the answer as coordinates. I was doing 8 and 6. I don't know why.
Yeah, so let's finish this one and make sure we can get it right. So Pythagorean Theorem says this is our side C. This could be A over here and this could be B. It doesn't matter what A and B are. They're interchangeable. Pythagorean Theorem says A squared plus B squared equals C squared. And so that means 8 squared plus 6 squared equals C squared. Let's see, that's 64. Oh, this one comes out nice. 64 plus 36 is 100. So what number can you square to get 100?
10.
Yeah, 10 squared. So C has to be 10 in this case. So those 2 points have to be 10 apart. And sometimes they work out nice and sometimes they don't. I think this problem I picked to always work out nice for the 2 points. Yeah. So it turns out, and I tried to, when I was talking about the Pythagorean Theorem, I talked about 2 things. I talked about areas and distances. It starts with areas, distances, but then works with the squares as areas. And together they always work out nice. Good question.
Elsie and I both did it like the other way, where it's like the x minus x.
You looked up the distance formula? Yeah, so I think this is way easier.
Yeah.
So that and I was hoping people would like Google distance. And if you Google the distance formula, you get this thing where they say, okay, you've got one point called x1, another point called x1, y1, other point is x2, y2, and then they just say, hey, the distance, by the way, is the square root of parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared. And all of that is in my picture without using x2, y2, x1, y1. So let's just go back and look at my picture and see that all of this is there without using that notation. So this point right here is the point -5, -3. That's my x1 and y1. And then over here is my point 3,3. That's my x2 and y2. And by drawing the picture, I can pretty much see what happens when I subtract those y values. So that 6 right there is like taking y2 minus y1. That's 3 minus -3, which is the same as 3 plus 3, or 6. So the distance formula is the Pythagorean theorem in disguise. And I think it's way easier to draw it than worry about that formula. Excellent comment. Glad you both brought that up. Other questions?
I'll just ask my questions next class.
You should ask them.
Ask them now. Okay.
Please.
So the end, the repeating formula one.
Yes. Oh, good. I was hoping somebody would ask one of those. Okay. Do you remember your version? Do you have it written down? You're gonna look it up on your
My
computer?
computer?
No, stop. I was hoping you. So remember, you got to write these on paper. Put them on paper. I used to do notebook checks in this class. I'm thinking I might have to start again. Okay. Next class.
Next year.
Next year. Let's see. That's this section. Was that toward the end?
It's like the last
Yeah.
2 or 3.
Last 2 or 3? Okay, here we go. And I think, were these equally hard? I think these are equally hard. I'm going to go with the second one. All right, so the one I got was 0.6727272. What does the bar go over here? The 7.2, yeah. Okay. New page. So what we're looking at is repeating decimals as fractions. And I did a few examples in class. They're in the video. And here we have what I'm calling x equals 0.672, which can also be written as x equals 0.67272, repeating. Okay. And the indication there is only the 7.2 is repeating. The bar makes that more clear. All right, so the trick I gave last class, there's 2 versions of the trick. The way I mentioned the trick is find the repeating pattern, identify how many digits it is. It's 2 digits, right? 2 digits means I should multiply by 100. So next thing I want to do is consider what's 100x. That means I have to multiply by 100 on the other side, which is going to give me 0. Nope, sorry, it's not going to give me 0 point. It's going to give me 67.2727. Now, rewrite the other number underneath. So x equals 0.6727. Right? And I don't have to write all of the digits, but write enough so that you have a pattern. And then the question is, does the part that goes on forever, do those digits now line up? If they line up, you use the right power of 10. If they don't line up, then we did it wrong. Do they line up? I have at the end a 7 and a 7, a 2 and a 2, a 7 and a 7. What I'm concerned about is the infinite part. Are they lining up in the forever part? And the answer is yeah, they are. So subtract if you get that to line up. So what's 7 minus 7 over here on the right? 0. And next to those is going to be a 2 and a 2 and a 7 and a 7. So forever, I'm going to have zeros out there now. That's the goal. The forever part is the problem. Because we're humans, we can't do forever. So we got to eliminate the forever half somehow. And then just keep subtracting this way. 2 minus 2 is 0. 7 minus 7 is 0. 2 minus 6, I got to borrow. Now 12 minus 6 is 6. 6 minus 0 is 6, and then I have a 6. Okay, so I get 66.6, and then everything else zeroed out. What's that equal to on the other side?
99.
Okay, 99x. to get x alone, we divide by 99, so I get x equals 66.6 divided by 99. Now, I'm close to having a real fraction here. What's the problem with this, though? Is that how we usually write fractions? No, there's a decimal on the top. I got to get rid of that. Okay, how do I get rid of the decimal on the top? Multiply by 10. So I got to do that top and bottom. So this didn't come up yesterday, but it's something we know how to do. So now I get 666 divided by 990. And I'm pretty sure I didn't set this, I didn't care if it was reduced or not here. So I think we could just enter that, or we could reduce it. I thought it was enough work to get to this point. So I'm pretty sure the computer will take 666 over 990. Yep, I liked it. Now, here's the catch though. On a test, if you have to do this, do you ever check your answer button?
No.
So how would I check to see if that's right?
Would you just put that into a calculator?
Yeah, just put it into a calculator, see what happens. So right now, I'm going to make believe I didn't push that button. I'm just going to ask my calculator, what is 666 divided by 990? And if you missed the last class, this is in the end of the last video I posted on my YouTube channel. It says 0.6727272, which is the number I started with. Okay, let's try it again. Let's look at the previous problem I was given. This one says 3414141. I think the pattern is the 4-1 repeats. See if you can turn this into a proper fraction.
To see where they match up. You see here, since you're turning it by 100, grab the pieces that way. From there, you have to line them up into two numbers meet with each other. So right here, the 2, 8, the 2 and the 2 have like, and the 8 like match up together in the line. Yeah, so this is when they start lining up. So then it'll be 0 and it's right there. So 3 and 3 makes it 0, 1 minus 1 can't do that, so you borrow the 2. So then you just call 1 minus 4. So then you get 2 is 2.
Ooh, I made a mistake. Cool.
It's supposed to be an 8.
I didn't subtract right somewhere. Oh, that's an 8. Yes, I can't subtract. Good job. So correction, this is an 8, 8, and an 8. Yeah, that shows I was 1 off on that. I had a 0 instead of a 1. Good job, Elsie.
How to take 1 away?
Okay, so 338.
No, because you're just trying to call.
990. Ah, there we go. Thank you. So this is a little harder than the one we did in class. It's pretty much the same procedure. The subtraction was 1 step harder. Caitlin, how you doing? Did you get that one to come out?
But I'm not
Did you
doing
write it
that
down?
problem.
Some of it. I ran out of room.
So that's what I just
My
watched on
20
this
something.
one.
Because I put it in the wrong spot.
Yeah, so that's where I got
I'm
that.
just gonna do on the next one.
We're done.
That's okay.
So then from there, I timed
I
it by
know.
10.
I didn't watch the videos
Because
yet,
I
but I
got
just
two
put them in
numbers
like
up here,
that and it accepted my answer.
So then I times it by 10 and I times that by 10.
Yeah.
So then I got the
Oh.
427 over.
The computer is set up to have a default precision of 1,000, so yours are within 1,000. Even though they're the wrong numbers.
Yeah. Okay.
Which would be good on the homework, but if this shows up on a test.
Yeah.
Well, now
Well, now I know how to do
Okay,
it.
so I gotta edit the, okay,
yeah.
thank you for pointing that out, I gotta edit the program to check something. Okay, I'll make a note of that, thank you. Yeah, so those are, your answers work to the nearest 1,000, right? So your answer would be,
Yeah.
you type it into a calculator,
more sense.
you
Yeah.
don't
it
get the
just goes right
repeating
there.
part. Yeah, which, you know, for most days is fine. That wasn't the point of the problem. Okay. How's it going? You guys
Oh, I
stuck?
got
You
that
figured it out?
problem.
Jimmy,
Okay.
you doing okay?
Yeah, she just.
Does it make more sense now?
It makes more sense.
And Olivia, you doing all right? Okay,
So I was watching the video.
hang on one sec. Did you paint that on your computer?
No,
Oh,
it's just a,
you bought a cover?
yeah, in case it can pop on.
Okay, that's all right. I just, sorry.
I wish I could paint like that.
Um,
No, I'm not gonna. I can try to.
let's see. This is homework 6.4. Decimal accuracy. Let's see. Okay, other questions from homework.
Okay, so I was doing number 19 and I tried watching, or I guess I got number 19.
What
But
is number 19
20
about?
No, it was number 20, sorry.
What's it about?
The division with the square root at the bottom.
Like with the one we just did? You heard that?
Sort of.
I think there's like a 1 at the top.
Yeah, it's the one.
So it's just 1 over square root?
Yeah, and I tried to do it like
Yeah. So it's the same thing. So give me an example.
so it's 1 over the square root of 32.
So that one's actually even easier. So 32 is not a perfect square,
Yeah.
right? Yeah, it's not. Although it does simplify a little, it's still an irrational number. So the trick is to get, is the denominator rational? Answer is no.
No.
The trick with the square root is to just multiply by itself. Now, since this is a fraction, we have to do that in the top too. Right? Same thing as before. And then you just do your fraction multiplication. Multiplying across the top, we just get the square root of 32. Multiplying across the bottom, the root cancels, leaving just 32. And that's it.
Okay, so I don't know if I'm not putting it in right. I can show you my work.
It didn't like that?
So the first time I was trying it, I like put in my work.
Yeah.
I don't know if it's because
Which
I
number
put
is
a
it?
1 in front.
20? Okay, so mine should just be the square root of 50 over 50. So
Did it not
it
like that?
could
I
be,
put a 1.
oh, it said simplify. Yeah, it's gonna mark it wrong. Okay, let's simplify. I forgot about that. So what it means by simplify is really we gotta clean up the square root first. There's the square root of 32 simplify. And if you think about it, 32 factors. What times what?
16 times
16 times 2. Okay, the 16 factor?
2. Mm-hmm.
Okay, how's that factor?
2 and 8.
2 times 8, or
Or
4
4
times
times
4,
4,
either way,
yeah.
yep. And then 8 factors, that's 2 times 4, and we keep factoring until, remember we've done factors through before, and this is 2 times 2. The square root is looking for a pair of numbers. Do we have any pairs of numbers at the end?
Yeah.
And it turns out, here's a pair, and here's a pair. That guy doesn't have a partner. Every time we have a pair, it pops out of the root.
No, okay.
So another way to think about it is we just wrote that the square root of 32 is really 5 2's multiplied. And I can break that down further in just a bunch of square roots. It's the square root of 2 times 2. There's the square root of 2 times 2, and then we just have a square root of 2. This simplifies to 2, that simplifies to 2, that's just stuck the way it is. Yeah, so it turns out the square root of 32 is 4 times the square root of 2. Now we rationalize the denominator. So let's try that again. So we started with 1 over the square root of 32. The square root in the bottom cleans up to 1 over 4 times the square root of 2. And then here, all I need to do to multiply to clean it up is just get rid of the square root of 2. Cleaning it up, in the top, I have the square root of 2. In the bottom, what happens if I take the square root of 2 times the square root of 2? I get a 2 times 4, 8. So that should be the reduced answer right there.
Okay.
Let's try it for my square root of 50, just to make sure we're getting this. So I had 1 over the square root of 50. Does 50 factor? Okay, how does it factor?
225.
2 times 25. And 25 is nice because that's a perfect square. I recognize it right away, so I'm just going to stop. So that means what I have now is 1 over 2 times, square root of 2 times the square root of 25. And what's the square root of 25? 5. So that means what I have is 1 over 5 square root of 2. So I've cleaned up the root. What do I do with the square root now? I multiply top and bottom by it. And then clean it up. 1 times the square root of 2 is the square root of 2. Let's see, square root of 2 times 2 is 2, times 5 is 10. Now, again, I don't want to hit the check my answer button. How could I check this? Plug this into the calculator, the first thing, plug the last thing, make sure they match. Yeah, so I could double check that and then push the button. So on my calculator, 1 over the square root of 50 is about 0.14-ish versus the square root of 2 over 10, which is 0.14-ish. So they come out to the same number, so it looks like I did it right. So they didn't want the unreduced version, they want the reduced version.
Yeah, because the videos when I was watching them,
Yeah.
it like doesn't reduce like that.
Oh, I mistyped it. Yeah, and there's different ways to approach it, but that would be one way to do it. Okay, good question. Other questions?
So why did it equal 10?
Yep, sorry. So over here, I've got it. You okay with me going from here to here to here?
Yeah, I'm stuck.
Okay, square root of 2 times the square root of 2 is what? When you multiply a root by itself, it cancels the root. So essentially what I have here is 5 times 2. Because these guys together cancel out. Just give me a single 2.
Oh, okay.
Yeah, and that's the trick we're going on. What does it mean to be a square root? It's the number you multiply by itself to get it the inside. We're multiplying it by itself, which gives us just the inside. So that's where the 10 comes from. Yeah, similar up here for the 8. 2, square root of 2 times square root of 2 is 2. 2 times 4 gives me the 8. Okay, other questions? So glad you were asking questions today. You guys make me nervous when you don't. Okay, take a deep breath. You okay? All right. We're going to roll dice soon. Everything's going to calm down. No questions at the moment? Okay. So I have one I want to look at. Summer asked about it last class, and I forgot to talk to everybody about it. It's in section 6.3. That's what I want on the screen. And then previous. Previous. Nope. Previous again. I think it was the last question here. Nope. 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 Did I not put it in here? I swear it was in here. Okay, maybe I am in the wrong section. What was this section? Okay, I lost. Oh, there it is. Okay. Does anybody remember doing this problem here?
Yeah.
Okay. So I just want to talk about this one a little since I didn't get to talk about it in class last week. I have a spreadsheet template for it, which you could have checked out. And all you had to do is plug in the numbers you were given because it varies the rate and the amount for each person when you load the question. So, for example, this one gave me 14.3 and 5.9. So this already does percent. And balance is 4,000. So there's different ways to make these calculations. So before I do it on the spreadsheet, we'll just do a little bit on paper. So usually interest rates are annual. Meaning the whole percentage only applies to a whole year. If less than a year goes by, then you only get to use a fraction of the percentage. So annual percentage rate is usually abbreviated as APR. Whenever you're given a credit card statement, any kind of bank statement related to a loan, they're always going to state what the annual percentage rate is. If it's a credit card, they're also going to talk about your average daily balance. So anytime you have an annual percentage rate, you also have to think about your monthly rate and your daily rate. And so I asked you about each of those in there. And all you do on those rates, and this part of this was in the book too, let's suppose my annual interest rate was 10%. If a month goes by, that's not a whole year. So the bank is obligated to prorate the year. And there's many ways to do that. One way is to say a month is 1/12 of a year. So I should get 1/12 of 10%. Often when you do that, you get kind of messy decimals. Because if we asked a calculator what 1/12 of 10% is, some rounding is going to have to happen. So let's just call it 10 for 10%, divide it by 12. So I get 0.8333333. Right, so it doesn't come out to a nice number, and so we have to round a little bit. So according to my calculator, this is about 0. I'm just going to go to the nearest hundredth of a percent, 0.83%. Now, does it seem reasonable that this is less than 1%? We had 10. We split it up among 12 months. Shouldn't we get less than a whole for each month? So that's a reasonable answer. So we get about 0.83%. Now, the question is, though, are all months created equal? No. So that there was some follow-up in the table about that. Not all months are created the same way. It could be if the month was February. Well, this year, February has 29 days out of a total of how many days?
366.
Almost. 365 days.
But you're not counting the extra day in the year?
Oh, shit. Yeah, there's 366 that day. Oh, man, you're way ahead of me. Good job. Yeah, this year there are 366 days. There are just under 365 and a quarter days every time we go around the sun. So that's why we have a leap year every 4 years to kind of catch up with that quarter. However, it's just under a quarter. So every 400 years, we skip a leap year. I know, it's complicated.
Are we near the 400?
The last one was 2000.
Oh.
So in 2000, we skipped a leap year. Because we were getting too far. The quarter every 4 years was getting too ahead of the sun, or the Earth around the sun. So we had to back off a step to make the time about the same.
So in the year 2000, there was no.
Leap year. Correct.
But in
There was still a
2004.
February. Wait, so there was no.
There was no February 29th in the year 2000.
There should have been if it wasn't
Should've
the
been.
400.
If it wasn't the 400, yeah, if it wasn't the 400th year since the last time we did it. Right.
So I like
It's kind of weird, but that's the way it goes. Yeah, so the deal is, I mean, think about it. The Earth is spinning around the sun, right? The Earth is also spinning around its axis. Those two spins don't line up, is what's going on there.
No, I just feel like I know people who say that their birthday is on February 29th of 2000.
I'm pretty sure there wasn't a leap year in
Well,
2000.
if I go back
2000
on my
was-
calendar, it is.
2000
It
on
is
there.
there?
Yeah, because I
Okay,
I was
maybe-
supposed to
I
be
think
due
what
on
happened
that
in
day.
2000 is they added an extra leap year.
Okay,
I think they added an extra.
all right, we gotta look this up. What are the leap year
Because
rules?
I think that was.
Have you heard
I
of
was
Neil
supposed- that was my
deGrasse
birthday.
Tyson?
Yeah.
I was supposed to be
He was
born.
talking. I watched a podcast where he was saying that the year 2000 was special because of the leap year. I think.
So maybe there's a millennial rule too. It could be.
Yeah, every.
Okay, so every year that is exactly divisible by 4 is a leap year, except years that are divisible by 100. Oh, okay, there's the 100 rule. And then, okay, sorry, I had it backwards. So the next time we'll skip a leap year is in the year 2100. But then every 400 years, we put a leap year back in on the 100-year marker. Okay, sorry, I forgot about that other rule. Yeah, so changes in millennia then would be leap years. But changes in century are not unless they're every 400 century, every 4 centuries. The rules for determining when Easter is more complicated.
Oh yeah.
That's, yeah.
All right, so let me see, where were we? Yeah, okay, so this year it would be 29 out of 365, 366, sorry. October of this year versus October of last year, they'll be different. Be 31 out of 365 or 366. This year it'll be out of 366. And the bank, it turns out, has options as to which numbers they pick. They could go with the 112th. They could go with 329 out of 366. They could actually put 360 in the denominator. Do you know why they could do 360? Because some people argue that on average, each month is about 30 days, and 30 times 12 is how much? 360, so let's just say there's about 360 days in a year. So it turns out legally, in the denominator, they could use 360 days or 365, 366 on leap years. And then some people argued that was too complicated. So then they said, okay, you can use any whole number between 361 and 366 for the number of days in a year. And this is actually in legal books, right? It's crazy. If you're curious about it, there's a law called the Federal Truth in Lending Law that lists out all those details. But you will end up with slightly different results depending on whether you calculate the percentage by saying, there's also a daily rate. I forgot to put in here. How would I figure out the daily rate? A day is what out of a year?
Day out of a year.
Let's actually ignore leap years and call this 365.
Okay.
Because that's what I programmed into the homework problem, sorry. So a day is 1 out of 365 days. So then we would just prorate our interest rate by that fraction. But you'll get slightly different answers as to whether you make this calculation for the percent, or if you make this one round and then multiply by like 29 or 31. You get 2 different answers. And the homework problem, depending on your numbers, sometimes it takes either, sometimes it says your rounding's a little bit off. Okay. So I just wanted to demo that here, that rounding errors happen. Banks have options on how to deal with them, but there's a lot of wiggle room. So let's see, for my problem, where did it go? Over here. Let's look at the February interest amount for 14.3 on 4,000. So for the February amount for me, I have $4,000. and there's going to be, let's go with a regular year, 28 out of 365 days, and my interest rate was 14.3%. So calculate that on your calculator. Tell me what you get. And again, notice I turned that percent to a decimal. So what does that come out to be on a calculator? Okay, so I get about $43.88.
Yeah.
You got that too?
Mhm.
Okay. So that's one way to do this problem, by just saying, hey, here's the part of the year that's gone by, literally for February. Another way to think about it is to look at the average daily change in interest. And so that would be to take 1 out of 365 and multiply that by the interest rate. So that says my decimal version of the percent is that number right there. And if I apply that to 4,000, then each day I owe about how much? $1.57 per day. Okay, so let's look at that next. So what was this one again here?
It was 43 and 88 cents. if you're rounding.
88?
Yeah, because it's 879,
Okay,
so I was
so
rounding.
88. Yeah, so the other way to think about it is the daily amount. And daily, what was it, 150, there, 157. So daily, it's about 157. And so if you say, well, that's my average daily amount that I owe, how many days went by in February?
28.
Okay, so I should be able to take that times 28, and that should be a way to get the answer too. Let's see what that looks like.
It might be off just because I don't know if the first time you did 87.
Yeah. So the other one had 88 cents. The 9 rounds that up. That's 7 to an 8. And so now we're going to take this as 157, multiply it by 28, and we get 43.96, which is the right answer. $43.96 or $43.87. Don't they both seem reasonable? Yeah.
I mean,
So
they're just a couple cents
yeah.
off.
So there are a couple of cents off, but if that happens over and over again, isn't that going to add up? Yeah. So there are rules about the way banking works, and do banks always follow the rules exactly? Usually, sometimes they don't, and lawsuits ensue if somebody catches it. And sometimes people catch these little mistakes. For an individual, it might add up to a couple hundred or a couple thousand, but then all of a sudden this happened to 1 million people, and the bank's up for a huge loss. And sometimes there's class action lawsuits related to these miscalculations like this, because someone didn't pay attention to where things are rounded. And that wasn't necessarily the point of this problem, but there are different ways to make the calculations, and it depends on where you round, you might get other answers.
And so, how off could you be, like, on there? Because, like, on one
this
of them,
system right here?
Yeah, because one of them I
Yeah.
was 7 cents off.
Yeah.
And it just, I genuinely just gave up because it was like the last, it was the
Yeah, so
February
my advice to students in this system right here is if the system is ever doing something you don't like the way it's grading your answer, hit the message my instructor. I usually set it up so that you can be within 1,000th of the actual answer or 100th depending on the problem. Sometimes that leaves too much wiggle room, like that other problem you're working on. Sometimes it makes it too tight, like this one right here.
Okay.
Yeah, so this one I should loosen up to allow either of those answers. The other one I got to tighten up.
Yeah.
Problem is everything's different and it takes, time to figure out. Oh, sorry, I chewed up a cough drop and swallowed the big part. Oh, okay. So there are different ways. So on your version of this, if you don't like the way it graded you, go back in there and message me and I'll check it out. All right. We are done with this topic.